Welcome to the Cave of Science, and today we're going to look at ionic compounds, or if you want to refer to them as ionic bonds. And ionic bonds are the complete transfer of electrons from a metal to a nonmetal. Think the alkali metals, the alkali earth metals, the halogens, the oxygen family, and so forth. Some characteristics of ionic compounds: they have high melting and boiling points, they're hard and brittle, they are good insulators, and they conduct electricity when dissolved in water. I think sodium chloride would fit all of these particular characteristics. Well, let's go ahead and look at some diagrams of ionic bonding to make ionic compounds. So we always write the metal first, so we're going to look at sodium, and sodium has one valence electron. And we're going to combine that with chlorine. Chlorine, on the other hand, let's use a different color here. Chlorine, on the other hand, a halogen, has 7 valence electrons. And if you remember, every atom wants to have a full outer shell or fulfill the octet rule. So what's going to happen here is the chlorine has a great affinity for the one electron in sodium. Sodium's not going to gain 8, so it wants to get rid of its outermost electron, and it is going to transfer it into the chlorine ion. And if you remember correctly, so sodium's going to become a cation, and the chlorine is going to gain an electron, so it's going to become an anion. So if we look at this, see if we get my color in there. Here we go. I guess that'll work. So we have sodium, and it has its one electron that's going to be transferred over into the outermost energy level of the chlorine ion. So we're going to have chlorine here, and chlorine's going to have 7 electrons in its outermost energy level. So the chlorine now becomes a negative ion, seeing it picked up 1, it has a -1 charge. Sodium, on the other hand, lost 1, so it has a +1 charge. And so this right here really belongs to the chloride ion. 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 electrons in outermost level, so it's a very happy camper. Sodium lost its 1, so its inner shell is going to have 8 also. Let's look at another example here. Whoops, let's see if we can scroll down a little bit. There we go. And if we were to write the formula here, I should do this before we take off, would be sodium chloride. All right, let's look at another one here. Let's look at calcium. So calcium has 2 electrons in its outermost energy level. So it's not going to gain 6, it's going to want to get rid of 2. And let's combine it, this time with oxygen. Oxygen, if you remember correctly, has 6 electrons in its outermost energy level. And I'm just going to put these in there. So it's going to want to gain 2. Well, lo and behold, calcium wants to get rid of these, and the oxygen wants to gain. So it's going to transfer those right here to give oxygen 8 electrons in its outermost energy level. So let's go back here. So calcium is going to have a +2 charge because it lost 2 electrons, and they went over into the outermost energy level of oxygen. to, and again, electron's an electron, doesn't matter where it comes from. So now oxygen picked up 2, so it's going to have a -2 charge. So if we look here, 1, 2, 3, 4, 5, 6, 7, 8, oxygen's happy, calcium's happy because it got rid of its outermost 2, and it'll have 8 electrons in its inner shell. And if we look at this formula, we have 1 calcium and 1 oxygen, so we have calcium oxide. Let's look at one more example. And this time, let's look at what happens if we have 2 sodiums combining with 1 oxygen. So we have our sodium, and again, sodium has 1 electron in its outermost energy level, so it wants to get rid of it. Oxygen, on the other hand, has 6. So oxygen is going to want to pick up 2. So what's going to happen here is that the sodium electrons are going to be attracted to the oxygen. It has a great affinity for these. So if we were to look at this, we would have the sodium. We got 2 of them. And they are losing their electrons. They're losing their electrons to the oxygen. So we'll put 1 here and we'll put 1 there. Let's change the color here. All right, here's our oxygen, which already had 6. So these 2 here, and again, on electron's an electron, these 2 were really taking off the outermost energy level of the sodium. So it's the complete transfer. In this particular case, each sodium has a positive charge. Oxygen still has a -2 charge. But now our formula, and again, you write the metal first, is Na2, and we have 1 oxygen. So we have sodium oxide. All right, so that does it for ionic compounds with ionic bonding. Again, it's that complete transfer of the metal's outermost valence electrons to the outermost energy level of a nonmetal to fulfill the octet rule. So until next time.